Hi, in this video, we're going to take a look at yield to maturity. So in a previous video, we have shown different forms of the bonds. So we could have different maturities, different coupon rates, and different spot rates. So it's going to be very difficult, at least very unclear, as to how do we compare the actual return if we hold the bond to its maturity. So we need a universal discount rate or a universal return on those bonds so we can compare different bonds with different maturities and, of course, different coupon rates. So what is this rate that we need? It is actually the internal rate of return for this bond. So let's reuse that example that we have from the previous video, which is the bond with 3 years of maturity, and the R1, R2, R3 stays the same. And we're basically trying to calculate the internal rate of return for this bond. Okay, so we already know that the price of the bond is going to be 973.65. So basically we're saying if we invest this much at time 0, we're going to get the future cash flow of 30, 30, and 1030. So what is the internal rate of return here? And if we can reinvest our coupon at that IRR, which is internal rate of return, we should be able to equalize this price and its future cash flows. So how do we calculate that? Let's write the formula here. We already know how to do the pricing of the bond. So here we're trying to calculate this this IRR. Let's just call it Y here. Okay. So it becomes 30 over 1 plus R plus 30 over 1 plus R to the power of 2 and 1030 divided by 1 plus R to the power of 3. So we're trying to know what this Y or yield or the IRR of the bond is. Okay, so provided that we hold it to the maturity. Okay, so as you can see, this is another higher order polynomial, which is going to be very difficult to solve by hand. So we can use the help of the Excel. It has the yield to maturity function built into the Excel, or you can use any calculator online to get the yield to maturity for any bonds. So we just need to input the price of the bond and then the coupon rate and the maturity of the bond. And of course, the payment structure, which is, as I have stated before, we're going to assume that is paid annually and at the end of the year. Okay, so if you input this information, so the yield should give you a number around 3.95%. Okay, so this is the yield to maturity for a bond like this. Okay, so what type of bond? It has to have a face value of 1,000 as a coupon rate of 3% and a maturity of 3 years, and then the first discount rate or the 1 year spot rate is 1%, 2 year spot rate is 3%, and the 3 year spot rate is 4%. So such a bond will give you a yield to maturity of 3.95%. So essentially, this is the return for on this bond if you hold it to maturity. Or alternatively, you can think of, so this is that constant discount rate that equalizes our the future cash flow with the given price. Okay, so we always need the price first. So in reality, you can see, publicly traded bonds. So the price will be quoted. Okay, so you can always quote the given price as public information, and then these coupons will be public information again. So you can always work out the yield for any given bond with its price given. Okay, so again, it's going to be very difficult if you try to solve it by hand. It's almost impossible if you have like more than 3 years. But in some cases, you can do it by hand. So provided you only have 2 years, so the maturity is just 2 years. Let's take a look at this example. So let's sort of reuse or shorten that example again. So I only have 2 years now. The 1 year spot rate is 1%. The 2 year spot rate is going to be 3%. Okay, and coupon rate, let's just change a little bit to 4%. Okay, so as again, we need the yield to maturity. So what do we need before we can calculate that? We need the price first, right? So let's calculate the price using the discount rates or the spot rates here. Okay, so the first payment is going to be 40 divided by 1 plus 1%. And the second payment, which is also the last payment, is going to be 1,040 divided by 1 plus 3% to the power of 2. Okay, and that is going to give you the price of the bond. So if you do the calculations, it should get you should get 1,019.9 pounds. That's going to be your price for this bond. Okay, now how do we calculate the yield on this bond? Again, we're going to assume some constant discount rate here, which is our yield to maturity, that makes our price and future cash flows equal. Okay, so let's write it this way. So 40 divided by 1 plus y plus 1,040 divided by 1 plus y to the power of 2. Okay, and that is still exactly our price of 1,019.9 pounds. Okay, so can we solve this? Yes, by using the quadratic formula here. Okay, so let's just do it by hand. Okay, so let's just multiply both sides by 1 plus y to the power of 2. So this becomes 40 times 1 plus y plus 10,040, and that's going to be here 1,019.9 and 1 plus y to the power of 2. Okay, and what we can do next is to simplify this. Okay, so we can put it into the normal or our very familiarized form of a quadratic equation. So what's going to be the quadratic term? The coefficient on the quadratic term is going to be 1,019.9 y squared. And then what's going to be the next term with 1 as the exponential here? So it's going to be, or the coefficient on y itself. So remember, there's going to be 2y here. So 2 times this minus 40. Okay, so that should give you 1999.8y. And then you have the constant terms. Just move everything else to one side here, okay? To one side here. So we have here plus 1,019.9 and then minus 40 minus this thing. So you get a minus here actually. So we can write minus 60.1, and that's going to equal to 0, okay? And then we can apply the quadratic functions formula, which is minus b plus or minus the square root of b squared minus 4ac divided by the 2a here. Okay, I'm just going to quickly remind you of this. You should have prior knowledge to this if you don't. So make sure you do have your mathematics prepared. Okay, so if you have this, so a is the coefficient here, b is the coefficient of this, and c is the constant here. Let's just plug in the numbers and we can get at least 2 roots here. Okay, so the first x by y here, you will get to 2.96%. Okay, and the next one, it should give you a negative number here, which is going to be negative 1.99. It's not percent, but it's negative 1.99. And we're not going to use this because that's going to be, if you put it in percentage, that's going to be negative 200%, which does not make sense here. We're almost going to discard the negative roots in most of the cases. So we're going to stick with the positive root here. So with 2 years, we can actually calculate the yield to maturity with the help of our quadratic formula here. Okay, so but with 3 years or more, you can either do it by trial and error. So basically taking a guess. If it's higher, then if it's too high on the left hand side, or the price is too high, then we increase the yield. Then if the price is too low, then we decrease the yield. Okay, so basically we can try to approach that real number by trial and error, but it's going to again take a lot of time. So the thing is, you need to know the definition of yield to maturity. Okay, so that's basically the IRR. As I say again, the IRR, or the return, if you hold this bond to maturity, and you'll be able to reinvest all your coupons at that return rate. Okay, so that's how yield to maturity works. Or in a very simple way, if you think of it, it's just a constant discount rate that satisfies this the price of this bond, okay, or any bond. That's the constant discount rate, which is the yield. Okay, and with the yield, it's going to be easier for us to compare with different bonds. Yeah, so if we have different maturities, different coupon rates, I can always calculate the yield on these bonds, and then I will have a sense of return on different bonds. Okay, so that I don't have to worry about they either have different properties. Now I'm just going to look at the yield, and then I have like a great like an overall picture or the sense of what am I getting out of that bond. Okay, so I'll see you in the next video.